So let's talk about fault tolerance, right? So the importance of fault tolerance is to maintain the data integrity. So the data accessibility and data integrity. So the most important thing in big data is data. If you lose data, in not only in big data, in any type of enterprise application, so that's a catastrophic. So you cannot afford to lose the data. So some of the examples are time critical systems and bank applications. For instance, if you make a transaction on ATM machine, and if you lose that data, that's extremely risky for you and for the bank. So they cannot afford to do that. So what that means is, if there is a failure, they have to have a way to resurrect the data. And if there is a failure, they have to be able to continue without any disruption. So the importance of fault tolerance has two parts. One is to protect the data. Second one is protect the compute. So what that means is, you have a mission time critical solution, let's say trading. So that's the classic example. So if while trading is happening, if there is a failure on any particular server or a machine, or any type of subcomponent of your server, such as storage, you cannot afford to stop or bring down the system. You cannot have downtime. So you need to continue. So that means you need a backup server, or you need a backup compute engine to continue your application. So that means there are two things that are important. One is to protect your data, where you don't lose the data in the case of failure, and also you don't lose your application or the compute time. So those are the two things. And how do we do that? So there are lots of mechanisms. These are some of the mechanisms I'm going to talk about in big data context. So before Hadoop, so Hadoop was derived from something called Google File System. So the Google File System, HDFS, Hadoop Distributed File System, is derived from Google File System. So Google File System solved this problem before anybody did, because they have seen this problem ahead of everybody. So what that means is, they were dealing with a lot of web crawling data. There's a lot of data that comes to Google, and they have to process that data very quickly. And also they have to be able to predict what users are doing on their browsers. So to achieve that, so Google provided some kind of big data solution, which is Google File System. And then you need a fault tolerant. Google File System has to incorporate fault tolerance, because in case if you lose some of their servers where they store your data, when I say your data, if you click on Google today, the click stream they call it, you click on your certain website or certain image or certain things on your website, all that information is stored by Google on their servers. So that information has to be protected, and also that has to be computed in real time. How do you do that? So Google File System incorporated something called fault tolerance. So how do they do that? So there is something called replication. So that means your data is stored, every click you do, or any type of data Google collects from users, is stored on multiple machines and in at least 3 different instances. So there is a replication mechanism. So that means your data is replicated. That means if you lose instance 1, you still have 2 more. If you lose second one, you still have 1 more. But it always maintains 3 copies. So that means if you lose 1 copy, it again generates another copy. So you always have 3 copies. That way you never lose the data. So, and the second one is shadow master, in support to primary master. So what that means is, if you lose the compute node, and there is a backup node that's called shadow. So that shadow node takes over the compute and continue the processing. And also the other part is data integrity. So what is data integrity? If you write, let's say if I write my name Guru,